All right, so this is the notes for Tuesday, which was 10/20, and we just did a little bit of notes, not a whole lot. We also today did a quiz, and I'll show you which point we did the quiz, and we had some homework. You'll find the homework and the quiz, the links are in Google Classroom. So let's start with the notes. So all changes, both physical and chemical, require energy. And here we have the law of conservation of energy. This sounds just like the law of conservation of matter. Energy cannot be created. Get my pen going here. We can kind of think of energy being like a bank account. You can take money and you can put it into a bank and it'll sit in the bank until you're ready to use it again. And then you can pull the money back out. So we can deposit energy into something, or we can withdraw energy from something. Really, chemistry is all about tracking energy. The matter tends to follow the energy. The next thing we did is we looked at, and we used a PhET interactive to kind of play around with solids, liquids, and gases. And all we were doing to change a solid to a liquid to a gas is either removing heat or adding heat. Remember back to gas laws, when we add heat, we're increasing the speed of molecules. If we take heat away, we're decreasing the speed of the molecules. So we're going to zoom in here and draw some pictures of the molecular view of a solid. So solids are going to have very close spacing of the particles, and the particles are going to be arranged in an orderly way. So this would be particles in a solid. They are moving, but they're only moving slightly. They're very packed together, and they're going to hold the form. For a liquid, if this substance is changing into a liquid, the particles are going to be spaced out a little bit farther. The arrangement is kind of random. Again, the spacing's farther apart. It's going to fill whatever container that it's in. So you can see that there's kind of a level here for the liquid. For a gas, we've spent a lot of time talking about gases. The particles are going to be completely filling the container. They're going to be moving at a very high speed, and they're going to be spread very far apart. As far as solids having a definite or indefinite shape, well, of course, solids have a definite shape. Liquids are going to have an indefinite shape. They're going to take the shape of whatever container I have them in. And gases would also have an indefinite shape. It's going to completely fill whatever container that I put them in. For volume, solids are going to have a definite volume. The volume of the solid is not going to change. Liquids are also going to have a definite volume. I can pour the liquid from one container to another one, and it's always going to measure the same amount. Gases are different. They have an indefinite volume. The gases are going to take the volume of whatever container I put them in. If I put gas in a 2-liter container, it's going to take up 2 liters. If I put gas in a 1-liter container, it's going to take up the space of 1 liter. So the volume is going to change with a gas. Now the next one, intermolecular forces. I want you to add in a definition. When I say intermolecular forces, I'm talking about the attraction between particles. Now I choosing to use the word particles because the particles could be atoms, they could be molecules, they could be ions. All of those different things that we counted in the mole, those could be the particles that we're talking about. So to zoom back out, when I'm looking at a solid, the molecular forces between the particles in the solid are going to be strong. It's what keeps a solid, the strong intermolecular forces. In a liquid, you can see that the distance is greater between particles. They're moving more, so the intermolecular forces are going to be weaker. And then gases, which we've spent a lot of time on, there's going to be no attraction between particles, so the intermolecular forces are going to be none. At this point, we went ahead and jumped into matter. And matter can be broken down into one of two things, either a pure substance or a mixture. We're going to focus in on pure substances. When I mean pure substance, I mean that it is 100% the same substance. Now, the substance could be either an element or the substance could be a compound, but it's going to be 100% the same. Looking at the elements, whenever we're drawing an element in one of these particle diagrams, we're going to use the same color and the same size for the particles. So these would be atoms of an element. You're going to have one type of atom. Now, these could be joined together. If I had two purple ones like this, it would still be an element, but it would just be a diatomic element. So one type of atom, it doesn't necessarily have to be just one atom by itself. Let's take a look at compounds. In a compound, I'm going to have two or more different types of atoms and these are going to be combined together. So here we've got a gray one with two red ones, another gray one with two red ones, gray one with two red ones. These are all the same type of molecule. We've got two of one kind of element combined with one of another kind of element. This may be an example of water, H2O, or CO2. But this would be example, there's no other type of compound in here. This would be still a pure substance. We'd have pure water or pure carbon dioxide. Let's go ahead and take a look at the other side of this, which would be the mixtures. So mixtures are going to be either homogeneous. The homogene means same. Heterogene means different. So in a homogeneous mixture, here we have an element. Here we've got another element. These two atoms are the same type, so that would be another element. So we have a mixture here, but it looks like it's very well blended. So a homogeneous mixture, we could say, is well blended. When we look at the heterogeneous mixture, we've got different areas. So here we've got an area that has a high concentration of this type of molecule. This area has a high concentration of another kind of molecule. So here we're looking at things that are not well blended. Another way of saying this is we have areas of high concentration examples of homogeneous and heterogeneous mixtures. Kool-Aid would be a good example of a homogeneous mixture. Kool-Aid, it doesn't matter where I put my straw, whether it's at the bottom, the middle, or the top, it's always going to have the same flavor. For a heterogeneous mixture, a good example would be a salad. We could pick out bits of tomato or lettuce or onion. There are chunks of things in the salad, so that's a heterogeneous mix. And then we have a homogeneous mix. And here's the last part, and I'm going to go through and work through each one of these. It says identify the following particulate level diagrams as being elements, compounds, homogeneous mixtures, or heterogeneous mixtures, and then identify the state of matter as well. So I'm going to zoom in on each one and do it and talk through. So the first thing I'm going to do is I'm going to look at what I've got. Here are two of the same type of atoms joined together, so that's an element. Here's two other atoms joined together. They're different than the first one, so it's a different element. So this is a mixture of elements. Now I zoom out a little bit, and it looks like it's pretty well blended. So this is going to be a homogeneous mixture. Now, the phase of matter that this would be, these are all very well spread out. They're not organized at all, so that I would say this is in the gas phase. Moving on to the next one. I'm going to first identify the different particles. Well, that has to be an element. These two are the same type, so this is another element. This one right here, we've got a brown atom with 3 yellow ones joined together, so this is a compound. Now I'm going to zoom out a little bit and look at the whole thing. Well, it looks like these are pretty well blended, so this is another homogeneous mixture. And now for the phase of matter, again, these are very well spread out. They're not organized at all, so I would say this is a gas. On to the next one. Looking at my particles, these are not joined to anything, so that's an element. Another different kind of element, so we've got 2 different elements. Now looking at this, they are not well blended. So if it's not well blended, it's different in different parts, so it's going to be heterogeneous mixture. Now the phase of matter, it looks to me like there's almost 2 different liquids here. A level of liquid there and a level of liquid here. This looks to me like you might find in salad dressing, where you've got a liquid layer on top of another liquid layer, but these both look like they're liquids. They're not well organized, and the particles are spread apart pretty well. This one here looks like I've got 2 separate things. There's one thing with a very regular pattern and something where it's more spread apart and it's filling the container. So here we've got elements. Here I've got a different element. So I've definitely got 2 different elements, but they're not well blended, so this is going to be a heterogeneous mixture. And I would say I've got both a solid and a liquid. Right here's my solid, and the rest is liquid. Moving on to this one, I'm going to first look at my particles. I've got purple and blue, purple and blue. The whole thing is nothing but purple atoms combined with blue atoms, so those have to be a compound. There's no other different substance mixed in, so this is going to be a compound. And the phase of matter, I would say this is a gas. Again, it's spread out, and they're not well organized. Coming over to this one, I only have 1 type of particle, so that has to be an element. And they're very spread apart, so I would say this is a gas phase. On to the next one. Again, I've got 1 type of particle. These are the same color and same size, so this is an element. So these are molecules of an element. Now it's all the same type of element, so I know it's a pure substance. So this would have to be an element. There's no compound. As far as the phase of matter, this one's a little bit difficult. If you're looking at the pattern, it looks very organized, so that would go with solid. If you're looking at how it's filling the container, it would kind of go with a liquid. I'm going to say that this is a liquid. You could kind of make it a case for a solid also. Let's take a look at this one. So here we've got 1 type of particle that is organized with another kind of particle. It seems to be a very regular pattern. So I would say that this is a compound. And because it's a compound with a very regular pattern, I don't think that this is going to be, it's not like a heterogeneous mixture. This would be either a just a compound. So you could actually make a case for either one of these depending how you look at it. I'm going to say that this is a compound. The phase of matter, I'm going to say, because they're so closely spaced together, is a solid. And they're very regularly organized. On to this one. We have 1 type of particle. We've got orange with 2 black, orange with 2 black, orange with 2 black. There's nothing else mixed in, So this is going to be a compound. And the phase of matter is filling its container, so this would be a liquid. And that takes care of that one. And the last one. Here we've got the same type of molecule. It is in a very regular pattern. So I'm going to say that this is a solid, even though they're spread out pretty far. And the phase of matter would be solid, and I would say that this is a compound. So it's a pure substance. We only have one kind of compound. And that's what we did today. With the other thing, we did a quiz on solids, liquids, on elements, compounds, homogeneous and heterogeneous mixtures, and that is in Google Classroom. Bye-bye.